And as I was saying, when I saw the Angel of the North, it really struck me, and you'll find out why in a minute.
Mhm.
And here's another of his sculptures, and somebody said that they'd seen it. Who was that?
Me, I have.
Who was me?
Pat.
Pat.
All right. Sorry, I can't see you.
No, Pat.
Yeah.
Yes, it's a family name as well, Crosby. My
Yeah.
mother's family were called Crosby,
Oh,
and went there, so I always remember Crosby Beach. Yeah.
oh, good. And there are quite a lot, aren't there, spaced out?
Yes, yes,
Mhm.
yeah.
So where is it? And Pat will know where it is, but it's just north of Liverpool, there.
Mm,
In Crosby.
yes.
Mm.
And here we have the Angel of the
Angel of
North.
the North.
And
Gate.
as people will know, is at Gateshead, Tyneside.
Mhm.
And when I saw it, something really jumped out at me. I'll leave that thought with you for a minute.
Mhm.
Maybe you can think what it is that jumped out at me. So it's Gateshead, Tyneside. That is there. There's Newcastle, Gateshead, and there is the Angel of the North right next to the A1. So if you drive past it, you cannot miss it because it's so deep. And somebody said that something like 19, I don't know, a huge number of people per second every day see it.
Cool.
Mhm.
Mm.
So what was it that stood out for me? Here's a clue. Anybody any ideas yet?
Guitar.
Any others? What can you see there? Well, I'll tell you what I saw. Those
Oh,
vertical lines, those struts on the arms,
railings.
they're spread out unevenly. And as you go from the middle to the outside,
Mhm.
it gets very much bigger.
Yeah.
And that jumped out at me. Being a scientist, I sort of thought the spacing of those vertical strips on the arm shouted mathematical series.
Oh.
Does that ring any bells for anybody?
Yes.
All right, okay, good. So we're on the same page here. So let's just go a little bit into it. What's a mathematical series? And just the simple one is 1, 2, 3, 4, etc. And the series is a series because each term, each figure is related to the one before it and the one after it. And in this simple case, each term is the previous term added 1.
Mhm.
And another very similar but slightly less obvious one, 5, 9, 13, etc. And each term is the previous term plus 4. When you add to get the next term, that's an arithmetic series. You'll see where this is going in a minute, so just stick with me. As I said, the gaps in those series are equal, the ones on the previous slide, but the spaces in the Angel of the North arms aren't. The spacing gets bigger the further away from the figure you go. Look at this series, 1, 2, 4, 8, 16, etc. This is obtained by multiplying the previous number by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, etc. When you multiply to get each term, that's called a geometric series. Note that the difference between each term gets bigger as you go along the series. That should start ringing bells now. So it looks as though the spacings of the Angel of the North figure form a geometric series. But what sort of series? Being a scientist, I decided to find out. So I measured the spacing on a photo. So I just printed a photo, got a ruler out and measured between the vertical parts of the arm. And those are the figures I got. And here they are printed out properly. They're only approximate because it was a ruler and a fairly small photograph.
20-something%.
Well done. Who said that? Is that John?
Yeah.
Well done, John. So I said, I'll go on and tell you how I got there. It makes it easier to proceed if the first figure is 1. So I divided each term by 6. That makes the first figure 1. And this doesn't change the relationship between them. And that's what you get if you divide each term by 6. And as John has already found out, this is what you get. So we have a set of spacings measured from the AOTN figure. I wonder whether they form a geometric series. It's going to be a simple one as it's a sculpture, not a mathematical exercise. So doing what John has already done in his head, to get an idea of that, you can divide each number by the one before it. So these are the measured values from the photograph. And this is what happens if you divide each number by the one before it. Very approximately, the multiplier turns out to be 1.2, as John has already said. It's not quite so, it's very approximate for the first one because that's a very small distance to measure. So the measuring errors are quite large. So to summarize, we know that the arm decoration spacings are 1, not random, 2, a geometric series, 3, such that each spacing is about 1.2 times the previous spacing, or as John so correctly said, 20%. And just to give you a break, those who are not so into all this as John is, I thought, here's another Antony Gormley sculpture. This is called Work and is set high above Dewsbury. So where's Dewsbury? Here it is.
Just
Down the bottom left is Manchester, Rochdale, Huddersfield, and there's Dewsbury. And there's the sculpture in place in Dewsbury. I don't actually know what the building is, but I'm sure it's easy to find out. So back to what we were saying, we've worked out the spacing as a geometric series with a multiplier about 1.2. So we can calculate what that series is as follows. So this is a set of figures, each one multiplied, that one term multiplied by 1.2 to get the next term and so on. And then if you look back at the measured series and compare the two, you can see that these are quite similar. Bear in mind that my measurements are approximate anyway. So you can illustrate that with a graph. So I've plotted the spacing on the y-axis and the vertical line number from the center there, and you can see the calculated figures are the blue line and the measured figures are the red line. And you can see that, give or take a bit here and there, they're really quite similar. So I was quite pleased at actually quantifying all of that. And something I've been thinking about for a long time, I actually got down and did it. So I was quite pleased with that too. For those who love mathematical formulae, the series can be represented by the following notation. This is just a mathematical shorthand for people who might be interested. So that's it. If you add it up, it's the sum that sigma sign means the sum of these terms with A equals 1 in this case and R equals 1.2, the figure we've come across, with n going from 1 to infinity. It's an infinite series. And that's the short mathematical way of representing it. And of course, in the real world, A will depend on the actual measurement. So it's going to be much more than 1. So to conclude, not many people ever thought about this, although I suspect John has. Have you, John?
Mhm.
Did you think about all of that before?
No, I was thinking of sort of stressing that if it was wings, I mean, they're going the wrong way to resist a bending moment. But if it was a bending moment, it gets less as you go out along the wing. So it doesn't get too much structure.
That's right.
So
So
that was my immediate thought as to why they got bigger.
yeah,
They don't need to be so close together. I
Yeah.
mean, not in the direction where it's actually, well, it is supporting because they're cross pieces.
Yeah.
But as you go out, the stresses get less.
yeah, that's interesting, and it's also interesting. Well, I think that's interesting.
So do I.
But I was looking at the just the visual representation to start,
Yeah.
and so I found spacing between the arm verticals follows a geometric series, and we worked out which one. I suspect that the series is as much to do with aesthetics as it is with stress analysis, but who knows?
Yes.
John, can I ask you a question then, or Ian for that matter? What you've just explained, I understand, and I was thinking, oh, it's probably a strength thing. If one was to look at aeroplane wings, would they have, the sort of the skeleton that you can't see? Would that have sort of unequal distances for the same sort of reasons?
That's quite possible. It would be
Yeah.
a sort of reason, wouldn't it?
If you looked at an aircraft wing and you cut it up, you'd find that the spars, which are vertical, they're on edge and running the length of the wing, would get shallower or lighter towards the end. I don't think the ribs would alter, the rib spacing, but definitely if you would look at the structure of an aircraft wing, it would get much lighter as you went away from the fuselage.
Thank you.
I don't think that applies to supersonic airplanes because they're just built like bricks anyway.
Yeah.
Do you think it is possible that the artist did it for a visual reason? I'm thinking of how we are fooled when we're coming on the motorway to a junction. Quite frequently, we come across these yellow lines across the motorway slip road, which start off very wide and get narrower or closer and closer together, which gives us the impression of speed and makes us fools us into slowing down. And I just wonder whether Gormley had something visually in mind rather than mathematics or strength, because the point you make about the bending moment on the wings is quite true, but the vertical struts wouldn't stop it bending in that plane, would it?
No, I know.
I suppose the answer to that is you'd have to actually email him and ask him.
Why not?
And I bet you'd get a reply because, obviously, well, I say obviously, how many people would have asked him such things, let alone noticed it, Ian?
Yeah.
Well, can I just say that I tried to email him because I've put in the chat box. Forget the first one; it's all three lumped together. But I put in the chat box those links, and if anybody wants to look at all of that again, there's a link to it on my website, McLauchlin.co.uk. And I tried to email him, Antony Gormley, and nowhere can you get hold of an email address. They want to protect themselves from time wasters and so on. and I couldn't find an email address anywhere. A couple of those links tell you more about the Angel of the North, and that Berkeley group has a website with a lot of information. Anybody more interested can look at that. And I emailed them to see if they could send the link to Antony Gormley. Got a standard email back saying, "Oh, can you be more specific?" And they listed all sorts of departments: welding, planning, and marketing, etc. So I sent the email to their marketing people. Haven't had any reply whatsoever. So if anybody can find an email address for Antony Gormley, I'm sure he'd be interested in all of this. I'd be interested to know how he designed the spacing of those struts. I think he's clearly used a geometric progression with as John says, with a 20% factor. But I wonder how much he was involved in that, or whether